Hello everyone. Today we are going to discuss about challenges in microgrid implementation. Last two videos we have been discussing about microgrid and its applications and its advantages. So we have discussed about microgrid. So microgrid basically creating the own local grid where we create power generation locally, we store the energy locally, and we supply the energy locally. So by doing this, we are removing the requirement of a transmission of electricity or transmission of power for a long distance. So we will have a 10-kilometer radius where we have a microgrids. So microgrids can be connected to the main grid if it is necessary when there's a need for export of and import of power from or to the grid. So likewise, sometimes we can have no grid at all, though some off-grid microgrid in remote locations like islands or very far away, 500 kilometers from the grid location, where we no need to bring the transmit power for this kind of long distances. Rather than transmitting power, we can have a microgrid. So that's and microgrid is environmentally friendly because we can have renewable power generation and it is locally produced. We are reducing losses and power losses and voltage drops. So there are a lot of benefits, but we still have challenges in implementation. So we are going to look at what are the challenges today in the implementing the microgrids. So first challenge is high initial cost. Because it's a new infrastructure, we already have a traditional infrastructure where we have a long transmission line and distribution lines with the transformers, all sort of things. Now we are going to introduce a new infrastructure. So initial investment for microgrids, including generation, storage, and control system, can be high, particularly for small communities, for organizations. So, because it's a new system where we are going to have local power generation, maybe through solar panels or wind power generation or CHP combined heat and power generation or mini hydro or whatever things, and we may be having a large size of batteries, and we need to have a microgrid controllers. So these are new addition. So this cost is high. That's the first challenge. The second challenge is regulatory and policy hurdles. So microgrid regulations vary widely by regions, often impacting grid interconnection standards, tariff structure, and revenue opportunities. So, what is the problem here? I mean, the regulations are changes between regions. Regulations mean there are a lot of regulations like how to operate, how to connect with the grid, what standard microgrid should be maintained. Because when the microgrid is selling power to the grid, grid will buy power from the grid. The power quality should be in a certain standard, and there are a lot of regulations how we both can share and deliver power to load. Sometimes microgrid together with the main grid has to operate parallelly to supply the power to the loads. So there are standards are varying. So grid interconnection standard, we know that synchronization concept. When we connect a load or anything to the grid, the generators, connected generators and the microgrid generators should have same frequency. So frequency matching, voltage matching, and power quality standards. These are the interconnection standards, grid interconnection standards. So that is influencing on these things, and tariff structures, revenue opportunities. These are changing between regions because in within a country there are different companies operating in the grid. So if we take Australia, there are two companies like Horizon Power and Western Power. They are operating in two different regions. So there can be difference in their standards. So that is one of the hurdle. And in India also, I think I'm not sure exactly. You may have different companies operating a different part of the power system. So That may be an issue. Okay, the complexity of system integration. Microgrid require sophisticated controls and coordination to ensure all components work effectively together. So it is a sophisticated control structure because we have renewable power generation, that is power can be generated only during the resources availability, like solar panels, solar radiation availability, wind power, wind speed, wind energy availability, and we need to store in the battery, we need to deliver. So it's a sophisticated system, and integrating renewable energy resources with energy storage and traditional generation can be technically challenging. So integrating renewable energy resources is technically challenging because we cannot is a time-based power generation. Time-based mean like whenever solar radiation available, during that time only we can produce solar power. So it is not dispatchable, non-dispatchable. We call in power system non-dispatchable power generation. It mean if I ask power in the night, if I need more power in the night time, we cannot produce any power from solar panels. So solar panels are non-dispatchable. Whenever I ask, it will not produce the power. So it produces power when solar radiations are available. So those are the challenges. So we need a huge storage system, and we need a lot of data collection, there are prediction needed. Those are the challenges and maintenance requirement. Microgrid with multiple generation resources, especially those with moving parts like diesel generation, require ongoing maintenance, which can increase operation costs because microgrid uses the diesel generators as a backup. Sometimes diesel generator continuously running if it is needed. Then these rotating machines need ongoing maintenance. That is having operational challenges. Uh, we come to the last slide where we are going to discuss about future of microgrids. So microgrids are expected to become a key part of the transition to a more decentralized and resilient energy system, because we are going to have a more decentralized and resilient energy system. Advances in energy storage, control technology, and renewable energy generation will make microgrid more affordable and efficient, expanding their use in both developed and developing regions. As climate resilience and energy independence become increasingly important, microgrid offer a viable solution for sustainable and reliable power. Because climate change is a major concern now. So climate resilience. So our system should capable of protecting environment, at least not harming the environment. So our thermal power plants are harming the environment, our other non-renewable power plants are not good for environment. So microgrid provide a viable solution because it is environmentally friendly and having many advantages, saving cost and all sort of things. Okay, I think that's all for today. So probably we discussed more about microgrid. We will try to provide a little more information about different topics in the microgrid in future videos. Bye for now. Thank you very much. Meet you in the next video.